All right, so getting back into law of sines. Once we've labeled our triangle like this, right, with opposite, angle and side with the same letter, in order to be able to use the law of sines, you have to have at least one pair where the angle and the side are given. Okay, so need at least one pair angle side given. Okay, so either both A's need to be given or both B's or both C's in order to use the law of sines. Otherwise, you have to find something else to use. Okay, now look at this problem. Okay, so let's talk about what the law of sines is. Once you have your triangle labeled ABC, okay, with opposite sides little a, little b, little c, then the law of sines is this. It basically says sine of A over A is the same as sine of B over B is the same as sine of C over C. And in order to use the law of sines, we can use any of the two ratios together. So I could use the A's with the C's or the B's with the A's and so on. Okay? Now, let's take a look at this first problem. It says solve triangle ABC. What does it mean to solve? Like triangle ABC. Yeah.
Find all of the angles and all of the
sides that are missing, right? So find all missing parts. Okay, we have some practice with this before. All right, so what am I missing here? I'm missing angle A. I'm missing little a. And I'm missing little c. Okay? All right. Now, you have to see, is there one pair where angle and side are given to you? Which ones? The B's, right? You have angle and side both given to you. So you start with those, and then you have to find one that you have at least one given. So what we're going to do is we're going to start with the B's. Sine of B over B equal to. Now, look at the A's. Both of them are missing. That's not a good place to start. But the C's, only one of them is missing. That's a good place to start. So I'm going to do sine of C over little c. Okay, now let's plug everything in. Sine of capital B, 53, over little b, 9, equal to sine of capital C, 100, over little c. All right, let me show you the easiest way to do this if you have a proportion like this. What would you do, by the way? You would cross multiply, and then you would have to divide. Okay, so let me show you the easiest one to do it. You write the unknown with a fraction. Okay? Now, look at the diagonal where both are complete. That's this one, right? So you do 9 times sine 100, and you divide by the one that you haven't touched yet, which is sine 53. Okay? Now, go ahead and take out your calculators, please. So we were going to plug in 9 times sine of 100. So 9 sine of 100 divided by sine of 53. It's absolutely important that you're in the correct mode, whether it's degree or radian. You have to be in degree mode. And so we have 11.098. And so go back in the instructions, and it says to the nearest tenth, right? So C is 11.098. So this is approximately 11.1. So my little c here is 11.1. Okay, now how can I find capital A? What am I going to do for capital A, for angle A? Well, is there an easier way? Mm, no. Well, you guys are so overthinking this. Look at you guys, all trig people here. Right. All three angles have to add up to 180. So you can just subtract from 180, right? So angle A is 180 minus 100 minus 53. Right? You guys are like totally overthinking. Oh, little a?
Yeah.
Yeah. So how much is this one? 180 minus 100 is 80. Minus 50 is 30. So 27, right? So 27 degrees. Now, for little a, I have to do the law of sines, right? I can't do Pythagorean because this is not a right triangle. So, for little a, I'm going to do sine of b over b equal to sine of a over a. So, that's going to be sine of 53 over 9 equal to sine of 27 over little a. So again, little a is equal to some fraction. I look at the diagonal that's complete, 9 sine 27, over what I haven't used yet, which is sine 53. All right? So now, if I go back, look, if you're using a calculator where you can edit, you can go back to what you just put in, select it, press enter, and now all I have to do is go in and modify this. So it's 9 sine 27 over sine 53. So little a is 5.1. Right? And there you have it. I found all three of my missing elements. So that is my answer right there. Okay? Yes? So before we even start, the only reason why we were able to use law of sines was what? What were we given? What combination were we given? We were given a pair, right? An angle and a side. Okay. So take a look at this one. I don't have a triangle here, but you know what? I can draw a triangle myself. So let's draw ourselves a triangle. Is NPQ. I don't care how you label your NPQ. Just start somewhere and go around. But you have to be consistent so that, okay, so Q is 110. Little q across from it is 11. Little n is 8. Okay? Now, you have to make a list of what you're missing. You're missing n, you're missing capital P, and little p. Okay, so how am I going to start this? Sine of what over what? Sine of which letter am I given both of the pairs? Q over little q equals sine of which one? The p's or the n's? The n's, because I don't have anything from the p's, so I can't do that. So sine of 110 over 11 equal to sine of big N over 8. Okay, so now this one's a little bit trickier. What's my unknown? Sine of n. I write that with a fraction. Now, take the diagonal that's complete. 8 sine 110 over what? 11, just 11, right? So now sine of n equals, let's see, 8 sine 110, 8 sine 110 over 11 is that. Is that my answer?
Nope.
No. What do I do now?
You have to divide by
Inverse. Good word. So n is inverse sine of 0.6834. So here I just do trig, inverse sine. Don't type the numbers back in, please. You will make a mistake. Just do the answer. Control, answer, enter. Okay, so it's 43.1 degrees. So big N is 43.1 degrees. Now, can I find P then? I'm just going to subtract from 180, right? 180 minus 43.1 minus 110, 26.9. Okay, what about little p? What am I going to do? Sine of q over q, sine of p over p. Do you see how if you make a mistake in one of them, a careless error, it's going to propagate, right? So it's going to not give you the right answer. So sine of 110 over 11 equals sine of 26.9 over little p. So p is, what goes on top? 11 sine 26.9 over what we haven't used yet, sine of 110. Okay, so go ahead and plug that in. Okay, so 5.3 for this one. All right, cool. Okay, so let's do one more. DEF. I'm going to start from here. DEF. E is 52. Little e is 5. F is 9. All right, so let's do this one a little bit more quickly. Sine of e over little e is sine of f over little f. So sine 52 over 5 is sine of f over 9. Ooh, I like this one. Okay, so my unknown is sine of f. What goes on top? 9 sine 52. What goes on the bottom? 5. Okay. So sine of f, let's plug it in. What do we get? I get 1.4184. So sine of f is 1.4. Huh? 9 sine 2 over 5. Is that what you typed? Do it again. Okay. Do you guys see anything peculiar about that? Sine. Huh? So we have a value here. Sine of something is more than 1. What's the highest sine will ever go? In between 1 and -1. This has surpassed it. So now, so what do you think? Is that even possible? It's not possible. So if now I want to go and find f, and if I do inverse sine of that, look at what happens. It's undefined. It's no solution. It's not possible, right? It's not possible. That means, so we got that because this combination gave us a sign value greater than 1. So what does that mean? That means you basically say no triangle. What that means is it is not possible to draw a triangle with these given parts, right? So it means like this side will be too short. Like there is no way you can connect them and make a full triangle, okay? So there is no possible way to draw a triangle so that one angle is 52, it faces a side of 5, and this is a length of 9. It's not possible to draw a triangle like that, okay? All right, so just know that it is possible to get no triangle. Okay, let's talk about area a little bit. Traditionally, we know that area is half times base times height, right? Half times base times some vertical value. Now, if you can't find that vertical value, based on the law of sines, we have different variations. So look, it's still half times a side times other stuff. So there are 3 variations of this, right? So one is area is half BC, these are the sides, sine of the other letter, right? That's how it works. Or half AC sine of the other letter, or half AB sine of the other letter. Okay? Now, let me show you a little trick to figuring this out. So suppose you have A, B, C, little a, little b, little c. So look at this first one. It's half times b times c. Oh, I did it wrong. Times half times b times c, right? And then which angle is it? This first one. Half b times c times sine of what? A. Where is angle A? In the middle of those two sides, right? So that's how it always works. So it's always the side in the middle, the angle in the middle of the two sides. Okay, let's find the area here. So area, look at what I'm given. This is side C. This is side B. So basically for this, you have to do half of two sides and the angle in the middle. So 3 centimeters times 6 centimeters times sine of 25. Okay? So this is 0.5 times 3 times 6 times sine of 25. 3.8. What are the units? Centimeters squared. So what you have to do is take two sides plus and the angle in between. All right, look at this one. Let's draw this. A, B, C. A is 30 degrees. B is 18. C is 22. Okay, we're going to do this without a calculator. Don't use calculators for this one. So area is going to be half, two sides, and the angle in the middle. So 22 times 18 times the sine of the angle in the middle. Okay, now check this out. Okay, it's half of these numbers. So I can cancel half with the 22 and get what? 11 times 18 times, hey guys, what's sine of 30? Do I need a calculator for that one even? What's sine of 30? It's pi over 6, but what's sine of pi over 6?
That's very good.
30?
Oh, no.
1/2. So now look, it's 11 times, can I take 1/2 of 18 like this? What does that give me? 9. So what's the area here?
99.
99 square meters. So see, you don't always need your calculator. So you can do this if you were stranded on some island and you had to find the area of this triangle. You could totally find the area of this triangle if you had to. Okay? All right, I'm going to pause here for today and pick up with the law of cosines next time. So let me tell you which homework problems I want you to do. You can actually do, guys, I would like you to do the ones until 17. So 1 through 5 odd and 11 to 17 odd. Do those. The homework is going to be like one continuous homework, but I do want you to do these for Friday, please, okay?